Okay, we're now ready for problem 28. So we're getting close to the end of these problems. Problem 28, solve the following exponential equation. And it gives a few more instructions. Let me write down the equation before I read the rest. 8 to the x minus 3 equals 64. And it says, express irrational solutions in exact form and as a decimal round to 3 decimal places. So I think what they're saying is when we solve for x, at first they don't want us to use our calculator to get an actual number. Just leave it. It might end up being some logs or whatever. Leave it like that. And then they say, then go ahead, grab your calculator, and give an actual decimal number. Now it's interesting how 28 and 29, let me write 29 here just to sort of talk about these two. Solve that equation, 4 to the x equals 9. Now we've talked about this before, but now here's a quick review. Way back, I don't know how many, 10, 12 problems ago, we had some exponential equations. And I said there are really two ways to solve these exponential equations. The first is if you can somehow get both sides to be exponents with the same base, then it's very easy to solve. But I said a lot of times it's impossible to get the same base on both sides. As a matter of fact, if I look at 29, I've got 40x over here and a 9 here. There's no way I can ever get the same base. Therefore, I said the second way we can solve these exponential equations is by using logs. So 29, definitely I'm going to have to solve by logs. 28, I actually could use logs if I wanted to. It'd be perfectly fine. But I also can look into trying to get the same base on both sides. And in this case, I think it's going to work. Because look, I have 64 over here. What is 64? 64 is 8 squared. So I really have 8 raised to the x minus 3 power equals 8 squared. So I got two exponents, same base. What does that mean? The exponents have to be equal. Now someone could go along on 28 and they could solve 28 using logs, just like I'm going to do on problem 29, and they will get the same answer. In my opinion, it's a lot more work, but nothing wrong with that, if that's what you prefer. But this method seems pretty simple. So now, let's do 29 right here. Oh, let's go back. So 28, they said, give the solution set. The solution set would be 5. And then the second question, and this is like the exact answer. So in this case, it's almost like they're expecting maybe the answer to have like a log or something in it. Turns out this one is so simple. It's just the number 5. So you put this for A. And then B, so A is like the exact answer. And then B is like grab your calculator and give the decimal answer. Of course, for this problem, it doesn't make sense. Although one goofy thing I see in the answer, because the second problem, they say round it to 3 decimal places. Sort of like they're assuming you're going to have some decimal number as your answer. Although actually the answer is 5. I see them in the answer key, they put this, which I think is sort of crazy, because I guess they want 3 decimal places, even though it's a whole number. Now, you know, on your test, when you're done, I go back and look at the problems you missed, and I can give partial credit. If someone for part B put down 5, and it counted wrong because it was 25.000, you know what I would do? I'd give you full credit. In other words, you got the problem correct. That's where they're sort of being silly. But now 29, it may apply. 29, we may have an exact answer, and then we go grab our calculators and find the decimal answer. Whoops, not 29. Yeah, it's 29. Sorry, I got confused there. So this one, I can never get the same base. Therefore, I'm going to take the log. Now actually, I think you guys are smart enough. Usually, if I show 2 ways to do a problem, I can sometimes confuse my students. But in this case, I'm going to show you the 2 ways to solve this. They both use logs, and they're not complicated. So I'm going to show you both ways, and honestly, it's your choice about how you want to do it. Let me see if the instructions... Okay, I'm just looking at this to make sure I'm not missing something. All right. So I know I'm going to take the log of both sides. This goes back to one of the purposes for logarithms. Remember, this is an exponential equation. The way I'm going to solve it is to turn it into a log equation. And the way we do that is we take the log of both sides. Now, the way I taught you initially is, when you take the log of this, I said it makes sense that you make the base of your log the same as the base of your exponent. So I'll take log base 4 of both sides. So the left-hand side, remember, we can move the x in front. And then we learned that other special rule about logs. Log base 4 are 4. If the base and the number inside the log is the same, this whole thing equals 1. So I get x equals log base 4 of 9. However, they don't really want you, and this isn't so great, but just know it now. When you give an answer on the test, they don't want you to leave your answer with one of these unusual bases. They really want the answer to be in common log, log base 10, or natural log. So what I'm going to do here is I'm going to use change of base, right? Log 4 of 9, change of base, if I change it to common log, this is log 9 over log 4. So that would be what we call the exact answer. Now let me show you a second way to do it, and I'm going to get the same answer, and you can choose which way you prefer. So over here, when I took the log of both sides, I made the base of my log the same as the base of the exponent. And that makes sense, and that's the way I initially taught it. Although actually, since I know they want my final answer to be log base 10, how about when I first start the problem, I go ahead, when I take the log of both sides, I make it log base 10. So I end up with this. Now, the rule about exponents still applies. If you have an exponent inside the log, it comes out front. So I have x times log 4, or common log 4 equals common log 9. So if I'm going to solve for x, divide both sides by log base 10 of 4. And you know what? Of course, you get the same answer. In my opinion, I guess if I was doing it on my own, I'd probably just take log base 10 of both sides. It's probably a little bit easier, but either way is fine. So this is the answer for part A. Then part B, they actually want you to give a decimal answer. That just means that you grab your calculator, and I think they say 3 decimal places. So 9 log divided by 4 log, and I have 1.5849, which means the 9 causes this to bump up, so it's 1.585 should be the answer. So, here is a problem, solving an exponential equation. The way we're going to solve it is, in a sense, we turn it into a log equation. We take the log of both sides, solve for x, you're on your way. Not too difficult. Now it looks like we have, what's the total problems? 34, 35. It looks like the rest of these are sort of like, I guess 35, sort of like story problems. But I think they're story problems where either you have an exponential equation or a log equation. So let's go ahead and stop now, and I'll start another video where we start to solve some of these story problems.